Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. Let's see, this is episode 7 of our live stream, and today we have Nathan Glover joining us, who is an AWS IoT hero. We will be talking with him about his insights around greengrass and some other topics. Um, let's see. My name is Dan Gross. I'm a senior developer advocate for FreeRTOS and AWS IoT. I am joined by my colleagues and co-hosts. Let's see who we have on the line. It looks like Alina is on the line. Hi, Alina.
Hi Dan, hi everyone, yeah, thanks for joining us. I'm Alina. I'm a senior developer advocate as well for AWS IoT for consumer and connectivity.
Awesome. How are you doing today?
All good. Enjoying the winter in Berlin.
Excellent. All right. It looks also like we have Syed on the line. Hi, Syed.
Hi, thank you for having me. And I'm also a senior developer advocate, just like the rest of my colleagues here. And good to meet you, Nathan. And yeah, looking forward for the conversation.
Awesome. Sounds good. Yeah, it looks like Nathan is also joining us. I think you're in speaker mode, so I believe you can hear us and unmute yourself if you like.
Yeah. Hey, it's good to join the show, and I'm excited to have a chat today.
Awesome. Well, thanks. Appreciate it. Appreciate you taking the time and joining us. Maybe a little intro about yourself. I mentioned that you were an AWS IoT hero, but um, maybe a little intro on how you've come to this IoT space, and actually even how you became an AWS IoT hero even. But first off, where are you joining us from?
Yeah. So I'm from Perth, Western Australia. So I think all the way around the other side of the world, sort of, from some of you folks.
Yeah, for sure. Wow, it must be rather late there.
It's about midnight, but it's usually when I'm up. So
Sounds good. Okay. So yeah, maybe
But
maybe tell us a little bit about yourself before we, get into some of the topics that we had planned.
Sure. Yeah. So my name's Nathan Glover. As you've already mentioned, I'm an AWS IoT hero. My current role, I am a senior platform engineer for a company called First Mode. We kind of build engineering solutions for clean energy. So we are currently working on a zero emission hydrogen haul truck. And I guess the primary role that I have at my current job is to kind of head up and work on our platform team, which is a fairly new team. And I guess what we do is, sorry, that's my cat. What we do is we basically build solutions that our dev teams can kind of move quickly with. So right now we want them to be able to move quickly, but also do things safely. And I guess that's where my role fits in. I help them and enable them to dev faster in a safe way. So I suppose prior to First Mode though, I worked as like a DevOps consultant, where I kind of helped just a bunch of different customers lift and shift and re-architect onto kind of more cloud-centric ways of working. So we're talking some kind of older like companies who've maybe not experienced the cloud before, but have a lot of existing kind of embedded systems. I've worked with customers who do robotics and customers who want capabilities to work in the cloud, but aren't really sure how to do that because not many people are kind of building in public with some of this kind of stuff. So I helped a lot in that space. I can go into a little bit more later on. And then I guess prior to that, I was actually trained. I wasn't trained as a software engineer. Actually, my background was like in sysadmin. So I spent about 5 years after high school just sort of doing computers and pretty quickly realized that I really enjoyed programming, but didn't really have an outlet for it. So you might have remembered hackathons were a really big thing back in like 2016, 2017. did a lot of those with just random people and met some of kind of my best friends. And that's kind of how I learned how to, I guess, develop and build, and sort of where it kind of landed me in the roles I'm doing now.
Oh, very interesting. Yeah. I think a lot of people end up in IoT in different ways. It's not necessarily a straight path into IoT. So yeah, that's very interesting. But it sounds like you're coming more from a DevOps side of things, sysadmin, DevOps, that sort of thing, than say an embedded or device starting point.
Yep.
That sounds very interesting. Like, how do you see the intersection of DevOps and IoT? Because I think in some ways, I think they do they can be a little contentious at times, but also there's obviously a lot of overlap.
Yeah, I think it's interesting because I came from kind of a more structured DevOps kind of, you want to iterate quickly, you want to get things out the door as fast as possible, you want to do it safely, you want to have tests, you want, everything to be infrastructure as code, like all these practices that I kind of had drilled into my head and that I was kind of implementing at customers when I moved into kind of more IoT and robotics sort of roles. What was interesting was that I looked in and said, "Oh, you're doing something wrong. You should be doing it this way because this is the new, the new way of doing things." And there was that sort of, it was a bit of a learning exercise for myself because I went in, I really understood the problem, and rather than kind of throwing, here's how you should be working at the problem, I looked at like what problems do we have when we're deploying devices to the field? How does technology enable us to solve those problems? And perhaps kind of the rigor around releases is more important than delivering features every single day. So I can go into more detail, but that's like kind of what I realized was obviously not every solution fits every problem.
Yeah, yeah. Maybe you could dive in a little bit more on
Yep.
some of your thoughts around that. That's a really interesting topic.
Sure. So I suppose for me, a big thing was around device provisioning, and this was sort of
Mm,
this is kind of a problem that I think most people who kind of go a little bit further than the Hello World examples in IoT projects kind of run into is which how do you manage fleets of devices? When I kind of moved into the IoT space and worked with kind of my first customer, they were a customer with about, a couple hundred devices, and I looked at the problem of how do we provision these devices? Well, I've used, CloudFormation, I've used CDK to manage infrastructure for previous projects, so it kind of makes sense to me. Like, let's try to use those patterns. And I pretty quickly realized that that might work for a couple devices, but as I started to sort of scale up, as I added more devices, it was more code I had to manage. It was more deployments I had to manage. The stacks started to become more of a problem. I was deploying hundreds of stack sets just to deploy device updates, and I knew it was not the right solution because I was having to engineer my way out of a lot of problems that
mm.
I created myself, if that makes sense.
Yeah, yeah, and especially when you're doing provisioning and having all of these things with certificates and there's a lot to manage, right?
Yep. Yeah, and I suppose, yeah, especially when working with certs, like I needed to export those certs from my stacks, and it was like, I'm not doing that securely. That stacks, those certs might be stored in the stack. They're not encrypted. It's like all these extra problems were being created just by the fact that I wanted to kind of solve the IoT problems in the same way that I was solving, deploying a serverless app or, deploying an EC2 instance with a database. I was trying to apply technology to the problem the wrong way, I believe.
Mhm.
Yeah, we view a lot of resources in the cloud as just kind of these expendable resources that we can tear down, build back up, those kinds of things. But real devices out on the edge are actually real devices. You can't just delete them and start over, right?
Yeah, definitely. It's once the cert's on the device and once it's out in the field, you have to deal with maintenance schedules. You need to deal with, potentially not having access to that device for weeks or months on end. So
Yeah, and I guess it's also a different way to look at infrastructure, right? Because I mean, some of the resources in IoT you can create statically, but I think a lot of the resources you need are dynamic resources, and that's where you have to draw the line. Like, what can you put, for example, in CloudFormation? What do you have to create on the fly as the device comes online the first time, and so on? And where is this balance?
yeah, definitely. And I think that's kind of leads into like how I eventually worked out I could solve the problem, which is to kind of look at uh, less about infrastructure as code and more about like configuration as code. So rather than treating my devices as individual things that I deploy, thinking of my groups of devices as well, groups and or fleets, and then providing just a standard configuration that I wanted to roll out to my fleets, and then I'm talking about it a bit later, but using something like Greengrass or not necessarily Greengrass, but using that to basically tell my fleet to say yourself to this configuration. If you can't align to that configuration, roll back to a previous configuration.
Yeah, yeah, really good. So what sort of techniques did you develop with this? Are you using all the standard tools, or did you have to sort of develop some kind of custom tools to accomplish some of this configuration as code?
Yep. So for me, so personally, currently right now, I'm using as much of AWS stuff as possible. So I'm using the standard deployment recipe and component patterns, which are part of Greengrass version 2. And I'm using the Greengrass, there's a deployment CLI that's available now that will effectively do like version bumping for you when you make changes to configs and deploy the assets for you and make a new deployment for your fleet of devices as well. So I've tried to keep everything as standard as possible or as aligned with how I guess the AWS tooling is built. I wouldn't say I've written too much custom stuff. We have custom components, but where possible, we try to lean on, I guess, managed services as much as possible. Because at the end of the day, someone has to maintain whatever code I write. And I don't necessarily want to look back 2 years' time and find some random Python script and hope that it works. So
Yeah, as some of these systems live on for a while, and as we develop our careers, sometimes these things come back to haunt us, don't they? So you think, gosh, what was I thinking back then when when I did this? And now I have to decipher my own code or my own setup, right?
And it's always the best when you look back and you say, who wrote this? And then you see, oh, it's me.
Right. So the class of devices that you're mostly dealing with are suitable for green grass. Is that right? That you've found that framework works for the class of devices that you're dealing with?
I'd say currently, yeah, it's very kind of suited to green grass in terms of we have a more of something that looks like a computer as opposed to like an embedded system. It's still not like a desktop computer you get at home or a laptop. It's a proper industrial grade, system, but it runs like a distribution of Linux. It's running x86. It's very much so. Like when you log into it, you get the same experiences. Like if you're working on a server or any kind of server, it feels like a computer. If that's probably as simple as I can put it. But,
yeah, so more gateways or these kinds of devices.
yeah, absolutely. It's got we've got systems around it that talk back to it. So we'll have embedded devices around the effectively what you said, the gateway or the edge.
Okay. Yeah, go ahead.
So yeah, in terms of I guess I could maybe talk about like why I feel like greengrass might lend itself pretty well to that problem. Because I suppose we're kind of using we're using greengrass for this sort of setup because it makes a lot of sense in terms of you have one source of truth kind of sitting in the middle and a bunch of systems outside that might want to publish data but might not necessarily need to connect to the internet, for example.
Yeah, actually, it might be good too to just touch on, why greengrass over, say, just an SDK or just a connector. I think those are some questions that I think people ask themselves. Can I just write an application that uses an MQTT client and go from there? Why do you find that greengrass is more suitable for the types of applications that you're doing?
So I think the thing that I usually run into where I realize I need greengrass is when I start streaming a lot of data, and I guess two things happen. One is I'm not necessarily going to be connected to the internet all the time, so I need to be able to buffer or cache that data somewhere, stream that data somewhere that's offline, that can be pushed online later. And the other thing is that I might want to be making decisions offline as well. So I want to be making decisions on the edge. I might want to have some of those other disparate systems that are offline be able to make decisions without being connected to the internet too. And I think where greengrass really sort of shines, because things can connect to it. It's able to operate, in a semi-isolated kind of network without too much problem.
Mm-hmm. And I suppose managing the updates and doing deployments and things makes life easier with greengrass, right?
It does, yeah. And the other thing that I kind of find, I think probably the thing that really we love the most about using greengrass is a stream manager. This was something that was available in greengrass version 1 as well, but for us it was a big problem is, how do we buffer data onto a device in a way that we know is not going to fail, in a way that we know data is going to be cached to disk or stored on disk and then pushed up when internet does come online. And you look at that problem and you think, that must be pretty easy to solve. We don't need to use greengrass. We can write our own kind of logic for data streaming, and then you kind of, it's a kind of an iceberg problem. The tip of the iceberg looks really simple, but the moment you delve into, how do we deal with log rotation? How do we deal with like what happens when disks fill up? How do all these problems get solved? And like Stream Manager, I think, is one of those components available in V2 and V1 where it kind of was a no-brainer for us. Like it solved that problem of we stream data from our devices to it, and then it handles streams of data up to AWS for us.
And how do you know what you sent and what you didn't send, and where those deltas are, right?
Yep. Yeah, definitely.
Yeah, I think Alina, you're dealing with some of that yourself now, aren't you? With MQTT.
Yeah. No, I'm currently working on a demo that I'm going to show in a week's time at a conference in Bucharest called DevCon. And my plan is to demonstrate how you can build resilience in your application on top of what MQTT as a protocol provides already for you, and how to understand these problems around resilience, how to understand what you still need to build on top, and also how to do it. And I started a little lower level, so I'm using the AWS IoT SDK. And sort of integrating it into a little simulator application. So yeah, it's actually interesting. the kind of problems that you have to solve, especially around guaranteed delivery of messages and just ensuring that your device is connected and stays connected and you know that it is connected. I mean, of course, you can throw it up there and you can just count on what MQTT by default on top of TCP provides you. But if you really want to know if it's connected and if all your data is actually being sent, then suddenly it becomes a little less trivial.
Yeah, absolutely. Like, I suppose I have a couple maybe follow-up questions to that. Like, what kind of ingestion, like, do you do anything special with the data when it gets up? Like, do you use rules or anything like that?
Yeah, so I think the demo is going to have two components, right? One of them's cloud and one of them's edge. So on the cloud side, I mean, I'm using rules, and then of course you can, follow multiple ingestion paths, right? So you can go from the rule to, directly an automatic integration, like into OpenSearch, for example, or into TimeStream. So that's one way to do it. And then you can also do it with a Kinesis stream into Firehose to make it more resilient. And then from Firehose into OpenSearch, for example, which also supports batches, right? So it allows you to ingest data into OpenSearch in batches, making it more efficient and a little less expensive. Or you can, if you feel courageous, you can go with a Lambda function and then use your own client. For example, you can use an OpenSearch client and write to Elasticsearch to OpenSearch yourself, or write into TimeStream yourself. So there are various mechanisms, but I think whatever it is that you're building, a very important aspect of it all is knowing that your data has arrived successfully and knowing when something fails, right? So one thing that people shouldn't miss is the error action on the rule engine. I mean, I think that's super valuable when you're working at scale. So yeah, I think the architecture overall is just a matter of what you need, right? So who your end data consumers are and what they need to do with the data. But no matter what problem you're trying to solve, you're not going to get around the fact that your data might not arrive and that there are multiple points of failure in your application.
Yeah, definitely. I think on the slight off topic, but when you talk about like what customers expect from your data, I suppose one thing we kind of ran into was like, how do you make the decision on like how much pre-processing we did at the edge versus how much we did, when it released, kind of arrived at the cloud, and that was always quite a difficult decision to kind of make. And I think it was nice that we could, with Greengrass, I guess, split streams off and have like our raw stream go up, but also provide like local processing and provide sort of separate streams that like other components on our device can use that are in like a kind of more pre-processed state, but still provide like a raw stream of telemetry up to the cloud.
Yeah, I mean, at least raw format is also quite important to store eventually. But I agree. I mean, if your device can actually handle doing processing at edge, then that's absolutely great. But if your device for some reason can't handle that, or if you simply think it's better to do this processing in the cloud, then you can you can also send all the data to the cloud, or most of the data. You can decide also on the fly. I mean, I think there are various mechanisms of doing this, but what I usually recommend, and I mean, when I was working in ProServe, it was relatively similar. I recommend that customers usually go with the highest level of abstraction that's possible for them, so that the maintenance code that you would otherwise have to write, you don't have to write anymore. So if something comes out of the box that does the job for you, then use that. But if it doesn't work, then you have to take the lower levels and start kind of going down on the abstraction level, slowly but surely.
Yeah, it reminds me. I watched a video that I think you put up last night on the rule engine stuff going to location service. And when I saw that, all I could think of was like, oh, that's great. Like, this is so much code that I don't no longer need to do, because if my device just publishes in this format, the rule engine can push straight to location.
Yeah, exactly. I think it's the same with OpenSearch, right? So I remember years back, I was working on a project. I think it was somewhere 2017, and I really had to write all the logic in Lambda to write to OpenSearch. I mean, to batch the data and just write it from Lambda to OpenSearch. And I mean, right now you have at least two different other ways to do it with managed integrations and managed services. So it's, I mean, I think it's great how everything has evolved.
Yeah, absolutely. Huge, like, I don't know, total cost of ownership for me is like, it's probably exactly the same for you, but I just don't want to, I go to bed a lot easier knowing that I'm not responsible for potentially a bunch of code that I'm going to have to maintain for the next 2 or 3 years, just because I want to do a little bit of data manipulation before it arrives somewhere else.
So do you find that you're spending more time then on configuration than, say, coding, either with Lambda functions or things like that? Is that a shift that you're seeing, that it actually is, more setup and configuration type of activities?
I think, yeah, like I definitely write a lot less code these days that I guess ends up on the devices. It is definitely more configuration, and that's probably more to do with, I suppose, my role being purely around that sort of centerpiece that all the embedded developers work around. So they usually won't need to control or write much code for Greengrass itself. They'll just write code for embedded systems around Greengrass. And I kind of like that a little bit, because it means that I get some, like personally, I still like getting in and actually writing the code, but I like that I'm able to sort of pull back and also not have to potentially write C embedded as my full-time job. I quite like kind of having a lot of different touch points within the business. I like being able to also work with data engineers and work on data problems at the same time as also working with, our embedded team. I definitely get, like, sounds bad, but I get bored really easily. So I really like being able to move around to different problems, and I find sitting in that centerpiece really lends itself to that.
Hmm. And it sounds like you mentioned components also. So you're using some of the community components, or contributing to them, or just leveraging them in some way.
Yeah, so we're using, I've written custom components for my own kind of, for some of the stuff we're using internally, but also just on some side projects I've been working on. And I really like the system versus version 1. Like, I used version 1 kind of way back. It was probably around 2018 when I first sort of dabbled with it, and it was good. It was definitely a lot better than anything else I'd used, but there were sort of some kind of gaping flaws that I felt around, like deploying code to it. I still felt like it was quite like a big bang release. Like, you'd have to bundle everything up you really wanted to deploy, even though it wasn't. I was probably just doing it wrong, but I feel like version 2 makes it a lot easier for you not to do it wrong, because the system in which you kind of build a component, version a component, it's got kind of its own namespace, and all you have to do to run the component is add it to your deployment. So your deployment is basically just a list of different components and the versions of those components. And it feels like a lot nicer now just to sort of send a YAML or a JSON file with all the components you want and all the configuration for those components, and then just have Greengrass sort of deal with how it's going to run all of those for you. I feel like it's just like, and I like that you also produce an artifact, and that artifact is like that deployment JSON that has, here's the system that worked, here's all the components and all the versions when in the last running state that we know was working. These are all the versions we were using, and this is all the configuration we're using. So it feels good in the sense that if I do break something, I can just roll back by redeploying that previous version, and I guess no one's the wiser, or it feels like it's easier to experiment with.
Yeah, and it's reproducible, right?
Definitely.
Much more reproducible. Yeah, that's great to hear. Yeah, moving from Greengrass version 1 to Greengrass version 2, we've heard there's been some bit of a transition overhead, but But in general, it sounds like it makes for deployments much easier. And the component framework, we should mention, is there is this community components that, I think, we should encourage anybody to contribute to and use for sure.
Yeah, I have they're quite good. I do have some kind of feedback for it though. I think that they supply a lot. There's a lot of kind of good things in there in terms of if you've got Grafana, you've got Influx, you've got Home Assistant, pretty much everything that kind of a hobbyist IoT kind of user might use. I think at the moment though, there's just not there. There is definitely a space where I think people could fill to provide kind of public components of like open source, open source projects that they might use. So if you're using, I'm pretty sure you already support like Node-RED, so I won't use Node-RED, but if you have like a particular thing you're using and there's not a component for it, I feel like there's a really good space right now where people could move in, write a component for it, and have it kind of available for other people to use. But I still think that there's a little bit of a gap between I've built this component, how do I kind of get it in front of other users to use? Because I don't believe there's a way to get it to show up in the console. And that's where I think if there was some way for that to happen, I think it'd be a lot easier to share kind of, community components basically.
Yeah, that's good feedback. We should figure out a way to do that.
Yeah, and also there's that side effect of the moment it's in the console, people are probably going to use it in production. So how do you deal with the fact that people are probably going to expect a certain level of rigor around this is going to work when I deploy it out to my production environment? So I do also definitely understand the problem there.
Yeah. It looks like we've had some new folks joining. So just to recap where we are, we're talking with Nathan Glover, who's joining us, who's an AWS IoT hero, and we're talking through topics around greengrass and other related IoT topics. We'll later on in the show we'll open up the floor for any comments or questions. Let's see. So is there anything else we wanted to touch on here, Nathan, before we move on?
I suppose in terms of just sort of probably kind of what I do still kind of gravitate towards more is what I like about Greengrass is the config applied to like fleets. I'm kind of curious in terms of not using Greengrass, like how do you sort of see people deploying lots and lots of devices? Like if you're not using Greengrass, how would you deploy a lot of devices? Like, do you have any recommendations around that?
That's a great question. Yeah, there are mechanisms for doing fleet management. Did you want to chime in there, Alina?
Yeah, sure. I think one of the most commonly used mechanism I would see is jobs. So you can use IoT jobs to deploy software, but also to send messages to your devices with configuration. So you can do it, one-to-many from the cloud. The templates are relatively easy to use, and they don't impose any kind of necessary needed fields or mandatory fields. So you just push a JSON object that your device understands, and then you can, in a flexible way, on the device side, parse the job object and act on the instructions sent from the cloud, which the device understands. So you can do configuration with this, but you can also do, of course, firmware upgrades. One thing that sometimes you might need to do is build a layer on top of jobs, perhaps, to do any more elaborate remote orchestration, and also catching the statuses from the devices, the interim statuses of your upgrade operation or of your configuration deployments and so on. So that's something that potentially you might have to build in your application if you want to do something more elaborate. But I would say jobs is actually quite a widely used service for deploying configuration and software to your devices. Have you got some experience, Nathan, with jobs?
I've touched them, like, not in a great deal. I suppose, like you mentioned, like I like that you're not kind of. I like when, because obviously using Greengrass, you kind of are locked into having to use a JDK since it all runs on Java. I like it when working devices where you don't necessarily have that option. You can be very specific about what you're actually going to run on those devices. And I haven't touched jobs enough to probably speak too much on them, but I do like that you have that flexibility to dig under the covers of kind of how this abstraction layer of Greengrass kind of works.
Yeah, exactly. So this is the kind of thing that I was talking about earlier as well, right? So it's about different levels of abstraction based on the problem you have to solve and the constraints that you're faced with in your application, what your device can do, what you can afford to do in the cloud with the setup that you have. And this is where the choices kind of come into play. I mean, with jobs, you do need to have a jobs agent running on your device that picks up on, the MQTT messages that come on particular topics and acts on them. But that jobs agent, you can build it yourself, or you can use some of the samples that have been published. You can build it in any programming language that you want to go for. So, build it in C. I think that as part of the device client, for example, you've got some examples of job agents, and there is, I believe, also a JavaScript sample that you can play with, or that people can play with. And I think the nicest thing is the grouping of devices in the cloud, right? So that's really powerful. The fact that you can run these dynamic queries based on certain device attributes and then perform operations at scale, right? So you can just go and say, give me all devices where the firmware version or the software version is 1.0.1, group them for me, and even maybe create me a dynamic group. So if any device comes online later with that particular property, then I can run or schedule a job to target all these devices and perform a firmware upgrade or perform a configuration. So it's quite powerful, but you do have to glue it all together based on the needs of your application.
Yeah, definitely. I think the grouping and the query API. Funny thing is the most we ever used that was actually for billing. Like at one of our customers, the people who used that the most was actually our accounts team, because they needed it to get billing information out, which is very odd. I don't know why they needed to specifically use that API, but I don't know. That was just one weird quirk that we'd used.
There is also, I'll add 2 cents of mine. We have a few workshops. So if you want to look at get started with awsiot.com, we have an advanced section in there to walk you through on setting up jobs. And also, if you want to deep dive into Greengrass components and using brokers within Greengrass, or using Greengrass on Windows, there's another workshop which is greengrassworkshop.com. So I thought I might as well mention these two things because you have a keen interest on that if you want to basically advance it further or dive deep further on specific sections. And happy to hear feedback from obviously yourself and other listeners.
I really enjoy those workshops. I find out of everything, out of all the content that I consume when I'm kind of learning something new, I always try to find those workshops, because especially with the Greengrass stuff, I was using it the other day for doing kind of local MQTT mosquito brokers. And I found just having that like actual kind of guide that tells you here's exactly what you need to do to get it running, as opposed to a bunch of sort of APIs and kind of nebulous instructions. Really, really handy. And yeah, actually used it a couple of days ago, specifically for local brokers to solve a couple of problems.
Very nice.
Yeah. So Nathan, I think you also mentioned that you've used RoboMaker with Greengrass. I was curious about that. Like, what kind of what kind of things have you been doing with RoboMaker?
Yeah, so one of my previous customers used uh, effectively just they had a bunch of robots that were doing kind of surveillance, not surveillance, they were doing like remote kind of autonomous rounds to basically look at their equipment and see if there was any flaws or malfunctions going on. And part of that was basically they had an existing robot operating system or ROS stack that they built kind of locally, internally. Everything worked really well, but I suppose getting ROS and actually running ROS on a device is quite an involved sort of process. It involves hardening an operating system, which, to be fair, you still need to do if you're running Greengrass. But um, a lot of the orchestration around how you actually run ROS jobs is kind of complicated. And if you look at in the the kind of robotics industry, a lot of the kind of solutions to that are people write really complicated bash scripts to run up a bunch of ROS nodes and ROS topic workers. And when RoboMaker came out, this particular customer was one of the first customers to use it. So we worked pretty closely actually with the service team early on to actually try and use the service, and found it really, really handy. And what I really liked about it was built on top of Greengrass, which there aren't many kind of examples of there. I'm sure there are plenty of examples that we don't really see where kind of Amazon is kind of eating their own dog food. They're actually using the services they build every single day, and working with RoboMaker was a really good kind of view into that, because you could see, when a RoboMaker job was deployed, you could go into the Greengrass console, or you could actually go into the Greengrass logs and actually see, oh, look, this is how RoboMaker is deploying to my device. This is really cool. I can see that Greengrass is being used by other service teams, and I found that really fascinating. I don't know, it just felt it was fun. Like whenever we ran into problems and we had to engage with the service team, like we could actually kind of see what they were able to see, because it was all deployed exactly the same way that we would deploy our apps.
That's really cool. And these robots were like visual inspection kind of robots or something.
Yeah, pretty much. So they were kind of Jackal robots that had kind of a bunch of different cameras. They had a lidar. They had some had microphones, some had gas meters, things like that. So it's a lot of just kind of tapping into the ROS topics, effectively just using Greengrass as a mechanism for taking all the ROS data and then siphoning off certain ROS topics and pushing them through to Stream Manager, and then from Stream Manager up to the cloud and to other various solutions that we had up there. So
cool. Yeah, that sounds like a fun project, just to explore your inner geek, right? All these things happening.
it was like, I don't know, like it was a great time, because like nobody was really using RoboMaker, so I had to kind of learn it all myself, and I found it like it was really hard, but it was also really fun. Like the service was easy to use. It was just, I felt like I was kind of I had like a lot of blog posts come out around that time that were really popular, and it just felt kind of cool to be kind of at that leading edge of like a service release, actually really using it on a customer, and actually, putting it to work in like production.
That's awesome. Yeah. Speaking of inner geek, a little bird told me that you were perhaps on a reality TV show that was related to geeks.
I was back in a while ago now. It was about 8, 9, oh gosh, 2013. Oh wow, time has flown. Yeah, I was on Beauty and the Geek over here in Australia. So we flew to Fiji, and I was on a reality show, which was very interesting.
That's amazing. That's amazing. Did you win?
I didn't. I got second.
Second? Oh, that's pretty good. How many
Which is,
how many contestants were there?
so it was 10 teams, but we were like knocked out, but we came back, so we were like a wild card. So
Oh,
I was on for
nice.
about 5 episodes.
That's great. That's great. I'm gonna have to go look search the archives for that.
a little embarrassing, but at the same time, it's like, it was fun. Like, it was an experience. That's what
Fantastic. So it looks like we actually have Nenad joining us today as well. Hey, Nenad, glad you could join. Oh, let's see. He's not set up as a speaker. Okay, well, anyway.
all good.
All good. We'll move on.
Yeah, sorry for being late. I hope you had a good discussion.
Oh, we had a great discussion. Yeah. We talked all about greengrass, your favorite topic.
Oh, no. I have to listen to the recording.
Yeah. I know you're coming in a little later, but any questions for Nathan around greengrass, or any comments you'd like to make? I know that you spend a lot of time with greengrass.
Yeah, I'm not sure you guys talked about this IoT DevOps and basically the blog. I think if you cover that already, then I'll have to rewind and listen.
Something I didn't cover was like kind of how, I guess, we kind of use GitHub, and what I kind of tried to build out was, whenever I build kind of examples, I like to include the kind of CI/CD, or the actual deployment method that I use to deploy it to my devices. Now, I wouldn't necessarily say that I'd use GitHub Actions to deploy out, thousands of fleets of devices. I'd still maybe want to have a manual step in there, but one part of like what I enjoy doing is kind of building out that, like what would continuous deployment kind of look like for IoT devices, especially when people are coming in who might not have much experience. Because I feel like there's a lot of the IoT stuff is kind of built in isolation. It's kind of built a little bit hidden, because at the end of the day, you have code on devices that are in people's houses. There's certain things you just don't want people to be looking at. You don't necessarily want them to fully understand how you deploy your things, because there might be some security implications to that. So definitely when I do my tutorials, I definitely try to cover the topics that I don't see covered enough. And I think continuous deployment is like a big thing for me. Like, how can people actually deploy these things, even if there are just little hobby things they're doing, like how could they do it in a way that like allows them to prototype quickly and try things out, and not necessarily have to SSH onto a device. How can they effectively build out of just an IDE?
Yeah, that makes sense.
Yeah, definitely building up. I've got some action templates that I could link.
Yeah, that would be cool.
That would be cool on my GitHub.
That would be cool to see kind of how this. I remember one of the things that we were doing was like putting a greengrass devices in a specific group, for example, dev and like prod. And then on the other side, we have a let's say a repository with certain branches. And then whenever something is merged to like dev, then basically AWS IoT job is triggered, or deployment is triggered, and then that goes on the dev group of those devices. But I'm really curious to see how you did this, and yeah, hopefully we'll take a look.
Yeah, definitely. And something else I always like to speak this, but the OpenID Connect kind of support for GitHub integration to AWS, so how you actually authenticate between GitHub and AWS was kind of released earlier this year, and I'm a huge adopter of that. We use it internally a lot, in terms of like kind of more of like a trustless kind of connection between our source control and the dev environments we use. So in some of the examples I've got effectively roles that you can assume from GitHub, get credentials, and deploy AWS IoT without needing to use access keys. Like there's no risk of you exposing access keys, because everything is kind of inherently trusted.
That's cool.
Yeah, we'll share some links after the live stream. We should include that as well. All right, great. We're approaching the top of the hour, so let's see. I'll open it up if anyone has any comments or questions, who's listening, that wants to wants to share, go ahead and request. I think I can see who's listening, and if anybody has anything, then I'll go ahead and make you a speaker. Okay, no takers at the moment. So what's next, Nathan? What are you working on? What are you working on next?
So I currently have an IoT treadmill. It's not actually an IoT treadmill. It is a internet-connected treadmill that someone has reverse engineered the Bluetooth protocol on, and I've hooked up to my Greengrass Raspberry Pi. And what I do is every time I walk on it, so basically it's like a desk treadmill. So you're walking while you're working, and I pull off some stats from that, and then push it up to the cloud. But something I was working on with this treadmill is I realized that I could use the data from the treadmill to control things. So I play a couple video games, and when I basically set it up so when I walk on the treadmill, I walk in the actual game.
Oh, wow. Now, is this a product, or is this something just a project that you've shared?
It's just a project. It's sort of it's very kind of, it doesn't work very great, but it's really funny in terms of kind of one of those things that, like, it shouldn't work, but it does work, and it's kind of fun because of that. So it's just like a off the shelf. It's definitely not a product. I very rarely actually build things to the point where I could release them as products.
So all you need is a Raspberry Pi and some code to make that happen.
Yeah, and similar to like last year, I did an Alexa cat feeder gadget. So I worked with the Alexa kind of APIs to basically. So when you say, "Hey Alexa, feed the cat," it'll basically get a call, and the cat feeder will open and close, which was a really fun project. Again, totally kind of impractical because my cats were super scared of it. Every time it triggered, they just ran away.
Alexa, scare the cats.
Yeah, pretty much.
That's funny. That's really great. Yeah, that's the works with Alexa API, right?
Yeah, it's the Alexa voice kit.
Yeah.
There's like a Bluetooth. I did a talk at reInvent in 2019 on it, when kind of it had just launched, and it's really powerful in terms of some of the effectively you connect to, or an Alexa connects over Bluetooth to your device for you, and kind of captures some of the invocations and some data from the invocations, and is able to act on it completely offline too, like basically through Bluetooth. So it's really great. Like, it's trying to avoid that problem of security because your device is just connected to Alexa. That's all it is. It's Bluetooth to Alexa, and that's how it's communicating. But yeah, off topic, but it was really interesting.
Yeah, that is. Okay, cool. Let's see. Any last questions or comments for Nathan here? All right. Sounds good. Well, thanks a lot for the time today, Nathan. Really appreciate you taking the time, and some really great insights around Greengrass. I think some feedback that we're gonna have to take back to the team, and just really great.
Yeah, thanks for having me. And yeah, if anyone has any questions, feel free to reach out. I'm happy to help, / provide advice / point you in a direction. Might not be the right direction, but it will be a direction.
That's great. All right. Yeah, we've been talking with Nathan Glover, who is an AWS IoT hero, and apparently Beauty and the Geek finalist as well. But no, it was a great conversation. Thanks a lot, Nathan, and thanks, Alina. Thanks, Nenad. Thanks, Syed. Really appreciate the time today. So we will wind things down, and we'll talk to you next week. Actually, a little bit different time, because the time change in the U.S. Will happen this weekend. So an hour earlier next week in the U.S., but I think the same time in Europe. Is that right?
Yes, that's correct.
All right, sounds good. All right, thanks again, Nathan, and thanks everyone. Talk to you next week.
Thank you.
Thanks, Tarim.